Today, we're diving into a chemistry classic, the isoelectric point, or pI. That's the pH where an amino acid has zero net charge. Not positive, not negative, but perfectly neutral. The pI is the pH at which an amino acid is electrostatically shoeless, a zwitterion, carrying both positive and negative charges that cancel out. It matters because knowing the pI lets us predict whether an amino acid will be positively or negatively charged at any given pH. Let's start with a basic amino acid. Backbone only. We've got amine, NH2, and carboxyl, COOH. Our group ignored for now. At low pH, where you have lots of hydrogen ions, both groups are protonated. Amine becomes NH3+, positively charged, so it's basic. Carboxyl keeps its hydrogen, so it's neutral. Total overall charge, +1. At high pH, lots of hydroxyls, OH negative, both groups lose protons. Amine deprotonates to NH2, neutral. Carboxyl becomes COO negative. Overall, the charge is -1. Now, at intermediate pH, around pI, amine is protonated, NH3+, and carboxyl is deprotonated, COO negative. Net charge equals 0. That's our zwitterion. Remember, zwitterions have both positive and negative charges, but a net charge of 0. To calculate pI, average the pKa values of the two relevant groups. If you don't know, pKa is just negative log base 10 of Ka. It's the acidity measure, so the lower the pKa, the stronger the acid. For a simple amino acid, consider this. pKa1 would be of the COOH, roughly 2.0. pKa2 would be of the NH3+, roughly 9.0. So the pI would be equal to the pKa1 plus the pKa2 divided by 2, the average. That comes out to about 5.5. If the R group has its own pKa, like in acidic or basic amino acids, include that in the average as well, taking the pKa values flanking the neutrally charged form. But don't worry, we'll go through examples of R group pKas in another video. Time to recap this short introduction. So at a low pH, the net charge is +1. At a high pH, the net charge is -1. At pI of roughly 5.5, it's 0. That's our zwitterion. And pI is the average of the two main pKa values. If this cleared up the pI mystery for you, I hope you'll consider hitting the like button and sharing your favorite weird amino acid in the comments. Plus, subscribe for more fun biochem. Thanks for watching.